Hi, this is Mrs. Secor, and if you could find this page in your notebook, we're going to do 2 pages today. We've been simplifying our radicals, and we've been multiplying our radicals, and now we're going to divide them. Okay, you're not allowed to have a radical in the denominator. So see the 25, the square root of 25? Well, this one's kind of easy because it's a perfect square. So all we're going to have to do is change that to a 5. So we have 4 square root of 15 over 2 times 5, the square root of 25, and we get 4 square root of 15 over 10. We still need to reduce 4 and 10. 2 goes into both of those. So it would be 2 square root of 15 over 5. We're done. Number 2 is very similar. We have a perfect square here in the denominator, so it's going to be easy to get rid of it. We're going to say 4. Oh, I think I can do better than that. Let me come back and erase that. Let's just cancel right now these two things. They cancel out. So we have the radical 6 in the numerator, which is allowed in the numerator, and we have a 2 in the denominator, and we're done. You can't cancel here because this is a whole number and this is a radical. They stand alone. Okay, number 3. Now here's where we have a different situation. How are we going to undo that? It's not a perfect square. It's the square root of 5. Well, we do a little trick. If we multiply something by 1, it doesn't change anything. So I'm going to multiply kind of a different looking 1, but it's still 1. I'm going to multiply by the square root of 5 over the square root of 5. This is good because it takes my denominator, square root of 5, and multiplies it by square root of 5, and that just gives me the square root of 25, or just 5, right? The square root of 5 times the square root of 5 is 5. Multiply up here on the top, 5 times 1, the invisible 1, gives me 5. Multiply inside, 2 times 5, gives me square root of 10. Almost done. I see I can cancel here. I'll do it in red here. Cancel the 5's. And then our final answer is the square root of 10. Alright, the next one. Again, I do not like this square root in the denominator. So I'll do my trick again, and I'll multiply by the square root of 6 over the square root of 6. Now, in my denominator, I have square root of 6 times square root of 6, 6. And my numerators, 4 times the invisible 1, 4, 10 times 6, 60. Oh dear. I didn't mean to give you such a hard one here. Okay, we're going to have to break our 60 down. I do happen to know that's 4 goes into that. I think it's 4 times 15. 4 times 15 is 60. All right, so let's clean this up. 2 and 3, we reduce 4, 6. And where should I go? Okay, I guess I'll go down here. 2 times, now 60 I'm going to break down to 4 and 15. That's what 60 is, and there's my 2. And I'm going to put it all over my denominator 3. Okay, so I have 2 times, this is now 2. 2 times 2 times square root of 15 over 3. Or I have 4 square root of 15 over 3. I'm sorry about that. That was harder than I intended to give you. Sorry. Alright, let's do the next one. This one's easier. Number 5. Okay, we'll multiply by our square root of 3 over our square root of 3 to make this radical disappear. 2 times 3, 6. Radical 6. 3 times 3 is 3. So it's 4, this 4 times 3. Square root of 6 over 12. Done. And the last one. Square root of 5 over square root of 5. 3 and 5 gives me square root of 15. 4 and radical 5 times radical 5 is 5. So it's the square root of 15 over 20. Seem to be having a problem here. Let's see. Okay, and one more page. Now, the reason we've been doing this is because there are two famous triangles. One of them is called the 45-45-90, which we're going to look at right now. And then tomorrow we'll look at the 30-60-90. This is a right triangle. If that angle is 45, we know this angle is 45. We also know it's isosceles. This leg equals this leg. Remember? This does appear on your OGT chart, your reference page, and they're showing you that these sides are both the same, the legs are the same, and the hypotenuse, the side across from the right angle, is whatever the leg is times the square root of 2. All right, so I always start with the leg and kind of call it my base, and it's 6. So I know this is isosceles. Y has to be 6. They're identical. They're congruent. And then the hypotenuse, well, it says up here, you take the leg times the square root of 2, and that'll give you the length of the hypotenuse. You're going to have to trust me on this. We'll do a couple problems. I hope I can prove it to you on the board when we get done with this video. Okay. Here is the second one. Now, look, I'm telling you that the hypotenuse is 5 square root of 2. The x is 5 square root of 2. So the legs must both be 5. Right? Well, if I do give you the hypotenuse like this, what you need to do is divide, instead of multiplying by radical 2 from the leg to the hypotenuse, you're going to divide by radical 2. Okay? 5 radical 2 divided by radical 2, they'd cancel out and you get 5. Now let's try a tricky one. The hypotenuse is 4. I want to get U and V, these legs that are the same. I just said to go from the hypotenuse to a leg, you go backwards, you divide by radical 2. 4 divided by radical 2. See why we just did the division? We can't have that in the denominator, so we have to rationalize it, is what it's called. We multiply by radical 2 over radical 2. Okay, so we'll clean this up. 4 radical 2 over radical 2 times radical 2 is 2. And these cancel. And you end up with 2 radical 2. So V is 2 radical 2, and so is U, 2 radical 2. All right, one more. The leg is 2 radical 2. So this other leg is 2 radical 2. Now we take the leg, and it says up here we multiply by a radical 2. Another radical 2? Yes. So we're going to say 2 radical 2 times radical 2 will give us our hypotenuse. And here we end up with 2, and radical 2 times radical 2 is 2, or the answer is 4. And thank you.